Well, hello, and welcome back. Tonight we are talking about regular expressions, which is basically kind of like a mini programming language that's based around text for being able to find, match patterns, replace, that sort of thing. So if you haven't done anything with regular expressions, you haven't heard about them before, don't worry. This is going to be, I wouldn't say that it's more advanced, but it's something that you learn in addition to your programming language that complements it when you're working with text and strings and such. So anyway, we're going to go ahead and dive right into it. What I'm going to suggest, I don't want you to rely on my cheat sheet. I want you to make your own. So go on and head on over to just.github.com. Maybe if you've got some Beyond Code notes already, open that back up and make a new file for regular expressions. You can call this, you might want to call it Regex or regexp, depending on what your flavor is. And I'm going to go back over here where we've got our notes and go ahead and get started. Okay, so let's talk about this in very simple terms. Let's say that you have some text. We'll go back to our canonical hello world. Oh, there it is right there. Yeah, let's do that. Let's say you want to determine, you're writing a bad word filter, and you want to determine if this has hell in it. And so you might do, in whatever language you're using, I'm using JavaScript right now because we can open this up in the web inspector and be able to play around and just see things live. And so I like that. So we could check to see if we have index of hell. And 0 in this case means that we do, because if we did not have it, it would be -1 for non-matches. And now let's say that we wanted something a little bit more concrete. We wanted to find out if because hell is part of hello, and so our bad word filter would fail on words that are perfectly okay. Now, I'm not going to necessarily recommend that you use regular expressions for a bad word filter because that could be disastrous in its own right, but it makes for a good example. So we've already reached the limitations of index of. What we could do is we could search to see if the string is in there. If it is, we could then kind of look ahead or behind the word to see if it meets other conditions. But essentially, we'd end up writing something that's more complex than a regular expression and doesn't give us as much value. So in JavaScript, strings have a .match, and the .match can accept a regular expression as a matcher. So let's say that we have our hell in here, and we want to see if that matches. And what we get back is this is a strange object because it's kind of an array and kind of an object. But what I want to point your attention to is right here where we have this 0, and it says that hell does match. But what if we wanted to match case insensitive? So we might do this. Now, one thing that's really common is, well, before we compare a string, we'd call .to lowercase or something like that, depending on what your language is. And then we'd get our match, and now we can see indeed the 0th, meaning the first match, is there. But with a regular expression, we don't even have to do that. We can put an I afterwards. So, oh, by the way, I didn't even explain. When you see a slash and then some letters and then another slash, that is typically in most languages, that is a literal regular expression, in the same way that something begins with a quote and ends with a quote is a literal string. And we can have an I after a regular expression, which will make it case insensitive. So then we can search, and we don't have to change the casing of the word. The expression will do it for us. Now, essentially, regular expressions are going to be very efficient. So the difference between using a match for a simple word and using, say, index of to determine if it's there, there's a little bit of extra overhead just as part of building up the regular expression, but it's still going to be just as fast. Like I said, they're kind of a mini programming language. So when they get run, they're pretty much just as fast as if you had written all the code by hand with all of the different checks, but it gives you a sub-language to do sort of certain checks. So I'm gonna go ahead and see if we can make this a little bit better with our original example. Then we're gonna go over that cheat sheet, and then we're gonna break things down bit by bit. I just want to show you a quick example first. So I'm gonna use \b, and this is special, just like \n, except that it's special for regular expressions, and it means word boundary, meaning that the character to the left is either not a word character, meaning it is not alphanumeric or underscore, or that it is the start of the line, or yeah, I think those are the conditions. And then we can do the same thing here. So now I have /b over here, /b over here. Now we'll see that this does not match. So this can be really powerful because it can give us a way to find particular words in a text or document if you're doing processing of PDFs or spreadsheets or something like that, and you just need to do some quick checks to see if a certain word or ID or something special is matching. This gives you tools to do that. It also gives you tools to reformat things. I'm going to give one more example before I go to the cheat sheet. So I'm working on an application right now where it would be really nice if the phone numbers were formatted properly like this or in any format consistently, but they're not. What will happen is one phone number is in a format like this, and then another phone number is in a format like this, and then another phone number might look like this. And then, of course, there are invalid phone numbers as well. And regular expressions give us a way to take different formats of text that are similar and be able to manipulate them. So I'm going to take my examples here that I just gave. We're going to do all three of these. And I'm just going to show you one more quick example and we'll dive into that cheat sheet. Okay. So I'm going to do my hyphens here. Okay, great. So now I've got this array that has 3 numbers in it. What I'm going to do is I'm going to loop over it with a function called map. Don't worry about that. But I just want to show you what I'm able to do with each of the numbers. So again, don't worry about the map. Don't worry about the function. I'm just going to take in this phone is going to be the variable that I'm going to have. This is what we want to pay attention to. And I'm going to return phone.replace. And I'm going to use a regular expression. I'm going to get rid of all non-numerical characters out of the string. So I'm going to match on all non-numerical, capital D. Lowercase d means digit. Capital D means not digit. So I'm going to match on all of those, and I'm going to get rid of any of the excess formatting there. So if we look at that, now each of these phone numbers looks a little bit better. And there's a couple things that I could do additionally. I'm not going to go through it right now. But in my program, what I did was I was able to format all phone numbers to look like this, no matter what format they were in. And I did a little bit of error detection to see whether they have 9 or 10 numbers or a different number of numbers, which would not be something that the program could handle, and it would have to display an error message. But that's kind of the benefit of it. So we're not going to go over all of this cheat sheet, but I am going to go over the things that I think are most important, and these are the things that I want you to take notes on. And the rest is just going to be here as a reference, and this is in the description of the video as well. Or actually, it might have skipped being in the description of the video. Give me 2 seconds here, and it will be in the description of the video. Okay, now it's in the description of the video. All right. So with that, we talked about what a literal regular expression looks like. This is the one that I would focus on. You take a slash, you start with a slash, you have some sort of pattern that's in between the slashes that will have some special characters for regex most of the time, and then you'll end in a slash and then IG. And the I means be case insensitive. That's what you want most of the time. And the G means to do what's a global search throughout the text. Basically, it means don't stop on the first match, but keep looking throughout the text. And I believe that this allows it to span across lines on individual matches, but not in between matches. And M allows you to have matches that span between lines. So a match could start on one line and end on another line. But this is the one that's important. This is the one that I use every day. So take note of that. We got a question in the comments that I want to address real quick. Why is index of not case sensitive? So I will answer that real quick. When you're doing a comparison in a programming language, the most efficient way to do it is to compare individual bytes. So we look at a string and we see hello, but in reality, there are some bytes to that. So if I'm going to do actually a new text encoder. This is a JavaScript feature that allows us to look at the bytes inside of a string. So I'm going to do inc equals new text encoder, inc.encode. I think this is right. And this should give us back, this will give us back what the bytes are. So there's a byte, there's a byte, there's a byte, there's a byte, there's a byte. This is the byte for H, capital H. This is the byte for E, L, L, and O. So when we're doing an index of, what it's actually comparing is, do the numbers match? So if we want to do a case-insensitive search, it actually has to change the numbers. So if I go and do this again, and I change the H, we see we get a completely different number, which is, before capital H is 72, and then lowercase h is 104. So that's why case sensitivity matters, is that it is less performant to, and also much of the time we want to be exact. We want things to be case sensitive because things, for example, a password, you would not, you should never be using index of on password, but just as an example, a password is case sensitive by nature. So that's why things would be case sensitive, or a couple of reasons. Okay, so I'm going to go back to here. Sorry for the divergence, but I wanted to answer that question. We go back to, we've got, this is this is the thing you need to make note of. This is what a regular expression will look like. It'll be different in different languages. For example, another way to create a regular expression in JavaScript, which is very similar to how you create it in Go, would be to use, in the case of Go, it would be regex.new. In the case of JavaScript, it's new regex. And then you give it the pattern as well as the options. But we'll talk about escapes in a second. When you use the string format, you have to use double escapes, and that can kind of get ugly, which is why I prefer the literal syntax when I can, because the more backslashes you have in something, the harder it becomes to read. But regular expressions are not easy to read. Okay, the next thing is there are literal characters. So what I showed here in this example was the literal characters NEEDLE. And basically your literal characters that you can count on pretty much always being literal are the A through Z, uppercase and lowercase, 0 through 9, and underscore. Many of the other characters have special meaning, and so sometimes they will need to be escaped. So that's what the escape is about. So we'll go into this. So that's the most important thing is just to understand regex is a way to search, and your pattern is what goes inside the regex, and it can have literal characters or special characters. That's the first thing. The second thing is capture groups, and this is, I'll be able to demonstrate escapes very easily. So a capture group, you can match more than one thing at a time. When we're using index of, we can match one string at a time. When we're using a regex, we can match multiple strings at a time, and we can say some things are important and some things are not important, like I did with, it kind of similar to the example of how I showed anything except for the numbers in a phone number is not important. I don't want those. So I used a regular expression as a replacer to match anything that wasn't a digit and replace it with nothing, which gave me back only the numbers. So that can be really useful, but there's other ways that it can be useful as well. Let's go back to our hello example. So I'm going to say, trying to think of a really good way to go about this. I prefer to do a non-contrived example if I can, but a lot of times you just got to go with the contrived examples. So let's just do this. We're going to say that we want to find he and LL as separate matches. Why we'd want to do that, I don't know. We'll get into some better examples later. But we can put this capture group, which is just parentheses, and instead of looking for parentheses, it's going to say, I'm going to search for the first pattern is everything in between the slashes, or everything that is the pattern. That's the 0th pattern, or the first pattern. Then this would be the first match, and this would be the second match. So if I run this, whoops, I need to make it case insensitive, and I need to get rid of that boundary nonsense. All right. If I match this, you'll notice that there are 3 matches here. The 0th, or first, because that's a little confusing, but that's the way we count in programming. So the 0th is the entire match, which is hell. And the first, or the second, again, index 1 is the HE, and you'll notice that it's matching the actual text. So we told it can do a case-insensitive match. It's returning us the actual text, not the case-insensitive text. It matches, but it preserves what the original was, and then we've got the LL. So let me do this another way to make this maybe a little bit more clear. I'll add an O onto the end. So then we can see our entire match of hello can be found, but our he can be found and our ul can be found as well. So this is a capture group. And this becomes important because sometimes, quite often, we want to look at one possible condition or another possible condition. I'm going to give another contrived example, but it'll suit our needs. Let's say that we don't want all letters to be matched case insensitive. Let's say that we only want the letter H to be case insensitive. So if I match hello, I get nothing. If I match hello with an uppercase, then it matches. Let's say I want to match both hello and hello. Right now, I just get the one match of hello. If I wanted to match both of those, I could use a group, and I could do uppercase H or lowercase h. And now we see that, oh, darn it. I need to switch this around to demonstrate. So don't mind what I'm doing here. I'm using a different function call because I think this is going to give me, dash it all. Let me try one more time. Sorry for the goofo here. There we are. Okay. I forgot to add my G at the end, so it wasn't doing a global search, meaning it was stopping at the very first search. But here we go. Now we can see that the match includes the uppercase hello and the lowercase hello. So there's a lot of situations like that where you want to match more than one thing, and you want to be able to say match this or that in front of this other thing or behind this other thing, etc. Okay, if I think the question is, if I typed 4 letters inside the parentheses, would it still count as 1? I think what that means is if I had put like this, what would this count as? And the answer is it's going to match either H or it's going to match hell, capital H or lowercase hell, and it's going to match O. So in that case, if we did hey, ho, hello, hello, we would see that it matches ho and hello. So I hope that answers that question. Feel free to follow up. So that's what a capture is. This is the second most important thing about a regular expression, is just knowing that there are captures and that you can use them in different ways. And then I need to show you one more thing, which would be how to match parentheses. And I'm going to get rid of my world so this can still fit on one line. So if we wanted to match literal parentheses, let me get rid of all of this. Hopefully you can guess this because we've gone through this sort of thing before. We would need to escape the parentheses to tell them not to act special. So if I want to match a parenthesis and another parenthesis, this will actually be kind of cool. I'm going to say what I want to do is I want to match anything inside parentheses. And so to do that, we haven't talked about this yet. We will in the cheat sheet in just a second. I'm going to put an inverted range, meaning an everything but. So I'm going to say, find, I know this is looking a little weird with all of these symbols in here, but what I'm saying is we're escaping the parentheses so it'll match as a character. Then this little bit right here is just saying, I'm defining a range, we'll talk about this in just a second, for anything except for a closing parentheses. And then we're going to find any number of those. We'll talk about quantity specifiers in just a second. And then we're going to find the closing parentheses. So the big thing is we're going to find an opening parentheses, a closing parentheses, and anything that is inside of it. So if I do that, it matches the whole of ho. Now let's go take a look at the cheat sheet, and I'm going to step through this because the capture ranges are something that I do think are very important. Along with capture groups, the big thing is we did talk about using parentheses. Oh, one other thing I needed to mention before we move on. Generally there's two styles of regular expression. There's the 1980 style, which is called Perl compatible regular expression. And then there's the 1990 style, which is called, well, I just call it JavaScript regular expression. So basically, most things are either JavaScript compatible or Perl compatible regular expression types. And the difference is whether or not, mostly it's whether or not certain special characters are treated as special characters or as pattern character. If you were in an older program like Vim or grep and you wanted to do a search with a capture group, the rules that I explained would actually be the opposite. So this is one thing to really be keenly aware of because it can mess you up, because this, as strange as it looks, is a very simple regular expression. If you create something that's very simple, like let's say we wanted to simplify this way down. If you were testing in a different programming language and you weren't able to get a parenthesis to match, then you might try removing the escape and seeing if it matches then, or adding an escape and see if it matches then, because different languages prioritize whether something is considered a literal character or given special meaning differently. And that's what I put in these tables is what things are escaped in Perl compatible regular expressions that aren't escaped in JavaScript regular expressions. And I think that Python is in the JavaScript style, but I'm not sure. It might be in the Perl style. You'd have to check and see. Okay. And then applying a group is for find and replace. So when you get to that, you'll know. Come back and take a look at this cheat sheet. I'm not going to go over it here. Quantity, I'm going to go over the first three, and then again, the other bit, you can come back and look. You'll know when you're ready for it. So a question mark means match 0 or 1 of something. Again, this comes in really simple or really handy with groups. So what might we want to match 0 or more of? In this, we might have to just go with a contrived example. But let's say that we want to match both the words hell and hello. Actually, a better one, a much better one that I use all the time, I'm going to come up with this example, is say we have a URL and we want to see if it is a secure, or we want to match both secure URLs and insecure URLs. I could use HTTPS and then a question mark. And I'm going to put this in a capture group just to kind of, not because we need a capture group, but just visually to be able to see it better, to understand what's going on right now. And sometimes I do this. I use capture groups more as a documentation bit than as anything else, just to make it a little easier to read. We can see that this matches HTTPS, but it will also match HTTP. So this is one that I personally use commonly when I'm matching URL styles. If I'm scraping links from a web page, I'll want to match both secure and insecure links. So there's an example of what 0 or 1 means. And then we already used the star. Star means 0 or more. So let's change our example here. Again, the capture group isn't important. I'm just using it more as a highlight feature than anything else. If we are to use a star here, then HTTP still matches and S still matches, but also SSSSSSS will match. Now, typically, it's not that's not something that you do is match a lot of S's, but you might match, let's say, a period. Now, a period is actually a special character in JavaScript regular expressions, as well as in Perl compatible regular expressions. So we need to escape it, otherwise it'll act as the special character by default. But if we did this, there are times when, for example, you might want to match period or ellipses. It's kind of a silly example, but let's just go with it. So say we want to match well, or we want to match well, and we might use something like I totally borked that. 0 or more. This would actually be where I wanted to match 1 or more. So I'm going to go on and move to the next one, which is plus. Anyway, so there we go. We get the match of the period, the single period, and the triple period, just as an example. So in general, I would say try to stay away from star when you can. If it doesn't really make sense, don't overuse it. In fact, one of the thing I put in the description that I haven't actually said yet is regular expressions are a lot like salt. A little goes a long way, and too much is too much. I generally will use very small, short regular expressions, and I might use multiple of them. I might match something, and then if the match that I wanted is there, I might take the pieces that I matched and run another regular expression on them, so that I'm dealing with regular expressions that are only a few characters long at a time, and I might match, say, part of a URL and then another part of a URL or something like that. It's kind of hard to come up with these examples for this type of scenario where we're going through some of this in a more live format. But plus means 1 or more. So, and plus has to be escaped in order to mean 1 or more in Perl compatible regular expressions. The between syntax, I'm not going to do any examples with, but basically if you use brackets, or in the case of the Perl compatible, the formatting here is wrong. I'll have to go back and fix the formatting on this. It was just going to show that there's an escape before each of these brackets. But this is, you could say there needs to be, for example, with a phone number, there needs to be between 9 and 10 numbers for a US phone number. If there's 10 numbers, we know it has a leading 1, or we can check to make sure that the first digit is a leading 1. If it's 9, then we know that we're omitting the leading 1. For example, stuff like that. And then we have ranges. And I'm really only going to show an example of the first 3 here. This one is the one that we need to be really careful of. The period means anything. And you're going to see a lot of people use a very bad pattern in regular expressions that leads to buggy code, code that isn't performant, and code that can even cause security vulnerabilities. So we want to be very careful about that. I'm going to show you what I do instead. In fact, I already have, but I'm going to go over it again. And then we've got these types of ranges, which we've already looked at. And then we have some specialty ranges that I'm not going to go over in full, but I'll go over briefly. So what we have with the dot, if I just do dot, you're going to notice that every single character gets its own individual match. So W-E-L-L, da 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 da. Everything gets its own match because dot matches anything. And this is not particularly useful. Most of the time, this is going to lead to bugs. It can be used for kind of some quick hacks. You need to know what it is, but you also need to know not to use it. That's what I'm going to say. So let me give you an example of a problem I come across frequently when I'm scraping websites. First, I might need to answer, why am I scraping websites? Well, sometimes an API that I want isn't available through the data that I'm trying to interact with. Like I can't get a nice JSON formatted data or a download from a SQL database. I have to kind of clandestinely just grab the web page and then figure out what to do from there. So this is the case even on, for example, I'm going to show you the Golang downloads. Their API is in HTML, and HTML is actually really hard to download. Let me see if I can find, where did they have their releases? Oh yeah, here it is. I think I can do something, I don't quite remember. I found out later that you can do something like format equals JSON or type equals JSON. We'll see if we can get this to appear. There is a way to get, there we go. It's mode equals JSON. So they happen to also have JSON, but before I realized that, their HTML is very well structured. If we were to look at it, it's very clean. It's very clear that it's been generated. So I'm just going to show you. Let me go to inspect real quick. Okay, yeah. And this is kind of big. It's kind of hard to see because the characters are so big. But if we were to look at the actual source for this, if I can get over to it, let me try this again. I know this is a little off the beaten path, but I just kind of want to get you to be able to see what we're working with here. Oh, goodness. What is going on? Oh, well. But what I was going to show is just the HTML actually looks really clean, and so it's very easy to use a regular expression on. And so sometimes I end up having to do things like that. So here we are. Let's say that there's a link in some HTML and it's to example.com, and then it says example in here. And what I want to do is I want to be able to match everything that's in the link. So what I would do is I would basically say, if I'm being lazy, I just need to look for href equals, and then we're going to put a range, and I'm going to say what can be in this range, or maybe range isn't even the right word. It's the collection, the allowed letters. So I'm going to say that there can be either a quote or it can be a single quote or a double quote, because sometimes URLs are formatted like this with a single quote. Sometimes they're formatted without any quote at all, and sometimes they have a double quote. So I'm going to say I can do an href equals, and then it can be a single quote or a double quote, but then I'm using a question mark, which means that it can be either 0 of these or it can be 1 of them in sequence. And then after that, I'm going to create a capture group. So I'm going to try to capture what the URL is itself. And for that, basically, I want to capture anything up until a quote or a closing bracket. So here, what I'm going to do is I'm going to say we want to capture not a quote, single quote, not a double quote, and not a closing bracket. And this is not 100% foolproof. There could be some weird reason that a URL has a closing bracket inside of quotes, but this will work 99.9% of the time. And, I can test to see if the site I'm trying to work with is that way or not. So I'm going to take this, and then I'm going to say any number of this. So 0 or more of anything but single quote, double quote, or closing bracket. Okay? And then I'm going to match up until, let's see, I'm going to match up until the closing bracket is what I care about. So anything that isn't a closing bracket, I'm going to match up until a closing bracket. I know this starts to look a little bit complex. This is how Regex is. But it got me my match mostly. Oh, I didn't use my capture group properly. So let me go back in here and let's see. Oh, I needed to do this maybe. Yeah, it's a little bit difficult to get it on the fly here. Sorry about that. Okay, so I'm going to get a little bit smaller and simpler. Okay, so that worked. Now let me see if I can set up my capture group for just the letter H. Yeah, okay, but my capture group is not working. What is going on? And I've got G specified, but it's not actually giving me my H separately, which is what I want. So I'm not sure what's going on there. I'm not going to live debug this. I made some sort of mistake. Sorry about that. But anyway, what I was going to show is that I would want to capture both the URL part, ignoring these two characters, and then I would want to capture the title. And I would want to be able to get that. Now, I'll put this aside for next time I do this video, that I'll make sure that I nail that example correctly, because that was something I was intending to show you. I'll just take 2 seconds to myself here. I hope you don't mind, and take a look. So we've got href equals. Let's just go ahead and see what we get up to this point. Okay, we've got one match. And let's see if I just put a capture group around this. Am I getting my capture group? No, why are my capture groups not working right now? Really not sure what's going on with that. It's got the G's right there. All right, well, I'm just going to have to move on from that and figure out what I did wrong later. So anyway, we can use any number of characters inside of this kind of this match group or range of characters, and we can use ranges as well. So I could say I only want to match lowercase a through z and then quote and maybe $sign, for example. And typically most of the things that are inside of here are not special. There's a couple of exceptions, one of which is the hyphen, because the hyphen defines a range. So this is not saying a or hyphen or z. This is actually saying all of the characters between a and z. So if we wanted to match a hyphen as well, we would typically put a hyphen at the end and escape it. Technically, it doesn't have to be escaped, but because it's a special character within that group, I like to escape it. Yeah, so we've got that. And then these are basically just shortcuts. So \W is a shortcut for all of the alphanumeric word characters, including underscore, because historically, underscore is an alphanumeric character, because you'll notice when you're programming, underscore is usually a valid part of a variable name. And so underscore is considered to be a character the same as A through Z is considered a character, just for historical reasons, even though it doesn't make sense. So that's something I'd say put in your notes, is to remember that when you're doing word matches, underscore matches as a character, hyphen does not. It seems like it'd be the opposite, because in the dictionary, hyphens are part of words sometimes. Underscores are not part of words in the dictionary. But this is just the way that it is for historical reasons. So if you wanted to be able to include hyphens, you'd have to copy this group and then add a hyphen to the end of it. This backslash should not be there. Actually, this is one of those things where my formatting in my cheat sheet is wrong. I'm just going to have to go back and fix that. So you can make note of that. And then The capital W just means the opposite of what W is. Likewise, D and capital D, D is only digits. Capital D is the opposite, anything but digits. Or rather, everything but digits. Lowercase s means types of spaces. So spaces are actually more than just this. There's a lot of characters that are considered spaces that we don't generally use in the modern era. But the common ones are an actual space, like you get with your space bar, a tab, like what you get when you hit your tab key, a return, which is what you get when you hit the return or enter key on the keyboard. And then a new line is basically, this has to do with old historical differences between the way that printers worked, the way that Mac worked, the way that Windows worked, and the way that Unix and Linux systems worked. Basically, a carriage return meant go back to the beginning of the line, and a new line meant go down one line. So this is back to the old typewriter days and old printer systems before there were monitors. It's important to know that because this pops up in a lot of places. It's also sometimes referred to as line feed rather than new line. So you have carriage return new line, or sometimes it's called carriage return line feed. That'll pop up in other places. So just something to note, /r/n. And then there are positional elements. And this is actually useful in a lot of stuff. So you're going to find when stuff pops up in your terminal and there's a big list of text, you can hit the // / is often, that's the normal slash, the slash that's in a URL, this kind of slash right here. So you can hit slash in just about any text. So let me go ahead and open up something that's going to have lots of text. So I open up something that has lots of text. I can hit /, and typically speaking, I can start entering in a regular expression and then hit the letter N for next, and it'll go through. Typically, these are what we call Vim key bindings. I actually want to test this one and see if I can do a true regular expression. Can I do E.**U? Yeah, I can. Okay. So in most applications in your terminal, just hitting / and typing a regular expression will allow you to search for something, say in documentation or whatever like this. And the other thing I was going to say is that caret is a regular expression for start of line, and $sign is a regular expression for end of line. And so if we wanted to match an exact string, I'll give you an example. So if we want to match hello with a regular expression, we can type in here hello. Oops. Let me just bring that back to the foreground there. So I've got the comments up. And that matches, but you know what else it matches? It also matches wello. So we get a match there as well. If we want to make it so that it's an exact match of hello, it starts with H and ends with O and has these other characters in the middle, then we would use the caret. And notice this is not inside of a range. So this means start of. When it's inside of a range, it means opposite of. And then we can do, fun things like, for example, it either needs to start with an H or it can have a space and then an H. This is essentially the same, like realistically, that's almost the same as if I was going to write the /B that I showed earlier. But I just, for demonstration purposes. So doing this right here is almost the same as doing this. But I just wanted to show, again, like how we can use capture groups and ORs and stuff like that. So that will give us an exact match of hello. That's all I wanted to show there. And then the other thing is that when you are in some sort of program in the terminal, typically speaking, hitting the caret will take you to the beginning of the line, and hitting the $sign will take you to the end of the line. So let me actually bring up something here. I'll bring up in Vim. So I'm in the middle of a line. I'm going to hit $sign. Boom. Now my cursor's at the end of the line. I'll hit caret. Boom. Now my cursor's at the beginning of the line. This is pretty common. And with that, I know that that was a lot of information. We actually went, as always, quite a bit longer than I thought we would. But this is, I think, If you can get this, if you can do a little practice with this, you essentially have everything that you need to know about regular expressions. And the stuff that goes beyond this, I would caution you. There's benefit to having a true mastery of regular expressions, but it also comes at a cost because regular expressions are not easy to read. So when you create regular expressions, you're going to need to do unit tests on these. So I'll give you an example. Let me see if I can copy and paste from something I had earlier. What I mean by unit test is, and I commonly will put this kind of stuff actually in comments in my code of what I have done tests against. So I'll say something like this: matches, doesn't match. And this is really important for security purposes because you may have heard about Zoom. They had a security breach where essentially they were just using a regular expression and their match was wrong. So in their case, they were looking for zoom.com as a URL that was allowed. And what it turned out is they had a bug in their regular expression. And so zoom.com.example.com, or let's say zoom.com.evilhacker.com, was also matching. And this was a huge 0-day vulnerability, meaning that it was so bad that it was recommended that everybody immediately patch their computer and uninstall Zoom that day, because it was very easy for anybody to just put up a website, evilhacker.com, give it a subdomain, zoom.com.evilhacker, and then gain access to any person's system that was running Zoom, which was virtually everybody. So this was a huge security risk, and this was part of the reason I believe that they acquired Keybase, which was a security company, or I guess they still kind of are, but now they're under the Zoom umbrella, is they needed people with security expertise to go figure that out. So anyway, what I was saying is, if I wanted to create a regular expression that matched zoom.com, right off the bat, this is wrong. It's wrong on so many levels. First of all, I would need to escape the period, because otherwise zoom.xcom would match. I also would need to make sure that I'm matching the end here. And let's say that I wanted to allow both zoom.com and www.zoom.com, right? Well, it's not sufficient to do this, because then evilzoom.com also matches. So I would need to do something like, let's define a group and say start of or escape dot matches. So now, if I were to test this out, and I did zoom.com, that's going to match. If I do evilzoom.com, that doesn't match. If I do zoom.com.evil, that doesn't match. And so what I do commonly when I have regular expressions is I'll put this kind of thing in the comments, and I'll make a little test file that runs some sort of test against a bunch of strings that are the evil bad strings that shouldn't be allowed and the good strings that should. And then maybe, I'll have the different capitalizations. This should be allowed. So I'll put a little case insensitive in there, because we don't care about casing on this particular thing. Oh, that was evil, so we're not doing that. But yeah, so that's how I make sure that I am testing my stuff and it looks good. But back to what I was saying, regular expressions are an extremely powerful and helpful tool, but they can also be very risky. They're like salt. A little goes a long way. If they're starting to get long and complicated, rather than being a regex ninja or a true regex master, I would recommend that you actually break your regular expression up into multiple parts and do a test on one thing and then another thing. So I'll give you a quick example of this, and then we'll end, because gosh, I went so long on this. But let's say, for example, we wanted to match Simver strings. So a Simver string can look at its most complex something like this. So Simver is the standard for versioning something. So if we say we have version 1, version 2, version 2.3.7, Simver.org explains what all of that means and what it needs to look like. And I think they finally did add a regular expression. Oh, they added a grammar. Oh, whew. Oh. So this is kind of like a long form of a regular expression, where they're defining what each variable as part of a string could be, and then they're defining something like numeric identifier, and then somewhere else they define numeric identifier as, eventually gets down to, okay, here we go, positive digit, letter, and so forth. So they get very, very granular, but this is kind of what a regular expression breaks down to in some regards. If you were to look at the code once it's all compiled, if you were to look at the binary bytes of it, you'd end up seeing something that is kind of somewhat sort of like this. Let's see. Yes, okay, finally. So I actually had requested that they put a canonical example of a regular expression. I have an issue open on the GitHub for this, and I believe they'd finally closed it out. And this is what the regular expression, oh my gosh, it's way too long. It's way too long. That just tells me that the standard itself is complicated. I would not use this regular expression because it is crazy. But if you want to get 90% of cases for this, what you could match on would be, it might start with the letter V or not. That's optional. It's going to have one or more digits, and then it's going to have a period, and then it's going to have one or more digits, and then it's going to have a period, and then it's going to have one or more digits, and then it's going to have a period, and then it may have a minus, and then anything up to a plus. And then it may have, so we need to put that with a question mark, and then it may have a plus, and I'm going to have to escape that so it doesn't behave like a special character. And then it may have anything after that till the end of the string. So I guess this might actually be an appropriate place to put a dot star, because every character after that is pretty much valid. So if we did this, and of course, I got it wrong. How could I possibly get it right on the first try? Too many dots. There we go. Beautiful. Beautiful. Amazing. I need to put one more capture group in there. So let me do this. Let's say we want to match on the major version and the minor version and, and the patch version. Okay, cool. So now I've essentially done a poor man's parser of a Simver version string that is not to the exact specification, but it's going to handle 99.9% of all cases, and it's pretty simple to read. So if I wanted to break it up more than that, I would not create a super long regular expression like this, because no one can understand what that means. I would take something relatively simple like this, and I would then break down the individual components that I needed to with some other check. But this is actually kind of cool. So there's our major version number, our minor version number, our patch number, our I think this is called release, and then our build. And then if I am not mistaken, I'm going to actually move this. I'm taking up a little extra time here for no good reason, maybe other than my own satisfaction. But I'm actually going to, no. I do have to put that in a capture group. So now we get to nested capture groups, which I say are highly suspect. Be very careful about doing nested capture groups, because this is going to be a little bit weird. I'll show you here. So now we have the capture group that has the minus in it and the other capture group. I think, one last thing, again, I'm just getting a little too excited, but I think if we put, a question mark colon in front of something, I think it negates the capture group. No. But that's getting too advanced. If you're getting that advanced, I think you're going too far in the regular expression. So I'm just going to leave it be. I was just kind of having fun there. All right. So anyway, and that did not work out the way that I wanted. One more. Okay, and then I'm going to let this go. I'm just going to let it go and let it be. Let's see. So I wanted to catch that. I wanted to catch this inside of that. Yeah? Is that what I wanted? Okay, cool. So anyway, now I have all of the different pieces of this parsed out. So hopefully those are a couple of practical examples. Hopefully that only makes your head spin a lot and not like explode. And if you've got any questions, please hit me up in the comments. If there's anything else that you'd like to see, please let me know. I know this was a really big video and a very big topic. If you have some suggestions for how I might better break this down, I would love to hear about it, or things that I should focus on first, particularly things that I should exclude from this. But I really think this right here is kind of your Regex masterclass. If you know these things, which granted it feels like a lot, but just start with those things that I highlighted. If you know these things, then you are doing well with regular expressions, and I don't think that you need to know much more. These are the very useful, very practical things if you're doing stuff like scraping, reformatting data, searches through your code, because tools like grep and RG support regular expressions and other code search tools. So yeah, I think we'll stick with that. And then before I go, I just want to say, if this was useful for you, please give it a like. If you want to see more of these types of things, if you want to subscribe, this that you're watching right now is the live channel, and the link in the description below is the Beyond Code Bootcamp channel, where we have these edited and put in the proper order, because I'm recording some of these out of order. And with that, again, just thank you very much for joining in, and I will catch you later. Adios.